So push rods link our lifters to our rocker arms. So basically just making that connection because the cam and the lifters are so far away from the rocker arms and the valves themselves. So anytime you hear push rod engine, think overhead valve. There is one exception to that though that I'm aware of, and that's this picture up here. This is an engine that was used on some of the Hondas and Acuras in the 80s and early 90s. This engine, it's kind of hard to see, but we've got our piston here. We've got our valves up top. This engine actually has 4 valves per cylinder, so 2 intake, 2 exhaust. It's a little bit hard to see because everything's so shiny on this one. But up there on the top is our camshaft. So that's one of those hollow camshafts like we talked about. So linking that cam to this valve is basically a small rocker arm, or what we sometimes call a cam follower. So that load will push on the cam follower and force the valve open. The other little cylindrical piece you're seeing up there is basically this part here, which is what we call a hydraulic lash adjuster. So that's maintaining the proper clearance in the system. We're going to talk more about that very soon. So that's pretty typical overhead cam setup, right? Cam pushes on the follower or rocker arm, opens the valve. And then we have this hydraulic lash adjuster to maintain our clearance.
I don't think I'm going to allow that.
When we have 4 valves per cylinder though, normally we're dealing with dual overhead cam, right? Because that's a lot of valves to operate off of one cam. This engine is not dual overhead cam. This engine is just a single overhead cam. So to get over here to this other set of valves, we have sort of a very unique arrangement. We have a secondary rocker arm, which is that one kind of standing up at an angle there. So that's another rocker arm or camshaft follower, whichever term you prefer. Cam lobe is going to push on that. It also has a lash adjuster to maintain proper clearance. Instead of pushing on the valve directly, it pushes on a small push rod. So this is an overhead cam engine, but it has a push rod. Smaller than a typical overhead valve push rod, but it's a push rod nonetheless. That push rod comes over and pushes on another rocker arm, which has a pivot point here, and that rocker arm is what will actually operate the valves. So a whole lot of parts and pieces to make one cam operate all 4 valves. And that's why most manufacturers, when we do 4 valves per cylinder, we just do dual overhead cam.
That's the one I have.
Yep, that's your car right there.
Oh, good old buddy.
This one's a little bit shinier, but same thing.
A lot of big shiny.
With a small engine, right?
No, this is the Honda and Acura, they call their C-Series engine that they used in Acura Legends. I think some of the Preludes used it as well.
With the small engine, got the push rods too, don't they?
Yeah, but that would be overhead valves
Okay.
still. So, like I said, this is the one exception where we have an overhead cam, but there are still push rods. But in general, if you see a question on your homework or on a test about push rods, it's overhead valve. So I like to show you guys this exception just to where you know it's out there. But in general, push rods mean overhead valve. Okay, so here's a more typical setup, right? We got our cam, our lifter, our push rod, rocker arm, valve. On most engines like this, the push rods will be hollow. So in terms of lubrication on the system really starts at the lifter. We pump oil into that lifter. As I mentioned before, the cam is really relying on splash lubrication. So all the oil getting flung off the crankshaft and the connecting rods. So it's really not getting oil directly. So we get oil to the lifter. That oil from the lifter goes up through this hollow push rod to the rocker arm, lubricates the rocker arm, and then it's going to basically run down the rocker arm and help lubricate between the rocker arm and the tip of the valve. And then that's where our valve stem seal comes in place to help make sure all that oil doesn't just run down along the side of the valve. Any questions on that setup at all? So that's most overhead valve engines. There are some overhead valve engines where the push rods are solid, so they're not hollow. In that case, the lifters get their own lubrication directly, and then to lubricate the rocker arms, all of the rocker arms sit on a common shaft, and we send oil to that shaft itself. And from the shaft, oil gets sent to each one of the rocker arms. A lot of older Chrysler engines are that way, and some other manufacturers do the same thing. But most of the time, push rods are hollow. They're part of that lubrication system. So what's wrong here? You got some bent push rods. So sometimes push rods have a very obvious bend to them, sometimes a very, very slight bend. So like we showed in the video, a good way to check these is put them on either a nice flat table or a nice flat piece of glass and roll them. So if they're straight, they'll roll nice and even. If there's even the slightest bend to them, they'll sort of hop across the table or hop across a piece of glass. So how could this happen? How could we bend a push rod? Ideas? If it's loose, probably not. What's that? Yeah, basically too much pressure. We're trying to push something that doesn't want to move. So a couple of different ways this can happen. If you guys are careful, to understand on this one, the timing chain broke. So we actually had piston hit a valve. So that bent the push rod because piston hit the valve moved the rocker arm, but this push rod became the weak link in the system. Running the engine too fast, over revving it can sometimes bend push rods, but usually the most common thing is that the valve gets physically stuck somehow. So, for example, if we don't have proper clearance between the valve and the valve guide, and that valve gets stuck temporarily in the head, the push rod becomes a weak link in the system. So, if you have an engine where you have a bent push rod, you don't want to just replace the push rod, you need to figure out why the push rod bent. Because otherwise you're going to be buying lots and lots of push rods because you're going to keep putting push rods in. So there's a reason why it bent.
Are they pretty cheap?
Yeah, usually. Okay, so we're going to look at a few different overhead cam designs. So this is becoming a more popular overhead cam design, and basically just for the sake of simplicity. So on this one, rather than using the rocker arm or the camshaft follower, we've essentially placed our cam directly over the valve. Now, in a perfect world, it would be nice to just put the cam directly up against the valve, right? So the load just operates the valve directly. Realistically, though, that doesn't work too well. And the reason why is, obviously this is a giant valve, but on a typical valve, the tip of that valve is pretty small, right? So if we have this load pushing just directly on the tip of the valve, we have a lot of pressure over a very small area. And what that would tend to create is a lot of wear and tear on the valve stem tip and on the cam load. So that just doesn't really do it. So what we do is in between, we put what we sometimes call a lifter, or sometimes we call it a valve bucket or a cam bucket. So this lifter or valve bucket sits over the top of the valve, and all it does is gives us a much bigger, much wider surface for the load to operate on. Spreads out the load to where we have less pressure, less pounds per square inch of force on that load. So ultimately that creates a lot less wear and tear. But that's sort of our best case scenario because the only thing between the cam and the valve is just simply that bucket. So it's a very direct connection. So fewest number of parts and pieces that can wear out and fail. So that also brings us back into different types of valve training. And we've kind of dabbled in this a little bit, but now's a good time to look at it a little bit further. So we can have what we call a solid or mechanical valve train. So with a solid or mechanical valve train, our lifter, or whatever components we're using, are literally just solid. So there's no movable parts inside here. Sometimes they can be disassembled, but there's nothing that moves around. So on a solid or mechanical valve train, we have to have valve lash or valve clearance, because as these parts heat up, they're going to expand, right? When they expand, we don't want that valve to get pushed open slightly. So on a cold engine, we start out with some clearance. As the engine warms up, that clearance will start to get taken out, right? So it requires that adjustment. The good thing about that is being that it's pretty much all solid parts, there's not a whole lot that can go wrong with it. But when we have that valve lash, that valve clearance between components, what's going to be the byproduct of that? What will we notice as a driver, as a customer, potentially? Noise. So when we have that clearance, we're going to have some noise. So that valve train is going to tend to make sort of a light clicking sound, almost like a pen click. And it'll be worse when it's cold because we have the most clearance. As the engine warms up, it's going to get quieter. But that valve training is always going to make some noise. And periodically, we're going to have to go in there and make an adjustment, right? Because that clearance will change over time. So it does require some maintenance. When we have a hydraulic valve train, we're using either a hydraulic lifter or a hydraulic lash adjuster to actually maintain the proper clearance in the system. So this operates with zero lash or zero clearance. So whether the engine's cold or the engine's hot, we have no clearance in the system. But what it's able to do is adapt to those changes. So when the engine's cold, we have zero clearance in the system, which what's that going to do for our noise? We have no excess clearance. Basically no noise, right? Real quiet valve train. As the engine heats up and the parts expand, it will allow for that room for expansion, but still maintain zero lash or zero clearance. So when the engine's hot, we're not forcing the valve open, but we also still don't have any noise. So it's a very quiet valve train. What's going to operate these hydraulic lifters or hydraulic lash adjusters is oil pressure. So these use oil pressure to create that constant adjustment. On these, the only adjustment you do, if anything at all, is during initial assembly. So when you first put this valve train together, you may have to make an adjustment at that point. Other than that, once it's running, you never go in here and touch this ever again unless you're replacing parts. So it's basically a zero maintenance system. And that's a system a lot of vehicles use because it is quiet. How many of you guys have ever had an engine and you accidentally ran it a little bit low on oil? Okay, so some clues that we ran it low on oil. One would be that oil light comes on, right? What would be another clue that maybe we got our engine a little bit low on oil? That ticking sound, right? That clicking sound. That ticking or that clicking is usually because we're starving our hydraulic lifters or hydraulic lash adjusters for oil. So now we're creating clearance in our valve train. And so with a solid or mechanical valve train, that's basically the noise that you're going to have all the time. So on this particular system, we're using that cam bucket or valve bucket, and it has a little miniature hydraulic adjustment built in. So this valve train should be very quiet and should require basically no maintenance other than just making sure we do our oil changes. Everybody okay with that? So the other version of this same system would be to make this a solid or a mechanical system.